Well, thanks to everybody who came out. I know it's 5:30 at reInvent, and it's a Thursday too, so thank you. I'm Brad Beebe. I'm product manager with AWS, and today we're going to talk about graph approaches for cyber investigative analytics. Before we get too far along, how many people are already doing or interested in cyber investigative analytics? Show of hands. Cool. How many people are using graphs in some way? Okay. How many people are using graphs for cyber investigative analytics? Okay. Cool. So we have a nice agenda today. So we're going to talk a little bit. First, we're going to talk about how you can do visualizations for interactive investigations. In particular, we're going to do some demos with the GPU. We're going to talk about Amazon Neptune, which is the newest fully managed database service designed for graphs that was announced yesterday, and this is a service that I work on. We're going to talk about how you can put it all together, and we're going to show a demo. So with that, I would very much like to introduce Leo from Graphistry. Graphistry is a small company. It's just news today. They were announced as one of the NVIDIA portfolio companies for the GPU Open AI initiative. So with that, Leo's going to take it away.
All right. Thank you, Brad. Yeah, hi, everybody. So I'm Leo, the CEO over at Graphistry. So we're a Bay Area startup that's been doing some interesting things with GPUs for investigative technology. So I'll be going over a few things on the Graphistry stack today. And the first of all, I thought would be interesting is, and I think it was highlighted by Brad's earlier question of what's going on with investigation at a high level and how we think about it as a kind of a cross-cutting concern across multiple types of teams. And whether you're within security and you have multiple teams, or you're an anti-fraud or something like that and you have multiple teams, what we really mean by investigation, investigative analytics, and then starting to see, even if you're not thinking in graphs today, why that actually starts to get pretty interesting, and while maybe you're actually not even realizing it, but actually already doing some of that stuff, and kind of how the Graphistry team over the years working with Fortune 500 and deep intelligence agencies and things has been establishing techniques for doing that. And that kind of gets into the heart of the talk, which is once you kind of are conceptually there, there's actually a lot of interesting things happening. I'm going to be focusing on two particular things. The first is how Graphistry has been pioneering a lot of GPU technology on the client and the cloud to kind of scale up what's possible. And second of all, once you have these power tools, how do you actually put it in the hands of everybody across the enterprise, like across these investigative teams? And then finally, throughout this, we're going to circle back to the Neptune team and see how this starts playing together and how do you actually bring it to enterprise scale. So I thought it'd be interesting to start with a simple example. I'm just picking this out of the security space. I'll tie it back into other types of investigations. And this is, I think it's interesting to just kind of step back and say, what is an investigation? Kind of what are the problems? What are we actually trying to do here? So this is simple, example here is representative of something that maybe a tier 2 analyst, that maybe there's a bit of escalation already on an incident that happened. I'm doing it from security, so maybe it's an incident responder. And looks here, they might be responding to a log line that says IP 10.16.08. There's something involving a spear phishing email getting clicked. The time was maybe sometime last evening, and the vendor who caught that was our Blue Coat proxy logs. And so this is kind of a very normal thing for an investigation team to at some point somebody has to, something happens, somebody has to deal with it. And if you kind of turn on your TV and try to think about like how maybe Hollywood might think about what that means for somebody to go figure out what's going on with 10.16.08, you might see something like this. It's like, oh, it's 10.16.08. I'm going to go to the back room. I know that guy. Let's get the pin board out. It's the Russians, and it's something like that. Now, even if already it's escalated to a tier 2 team, which is already starting to get pretty fancy, the reality looks a bit more like this. And so I'm going to deconstruct that a little bit. So the first thing on the top is they've probably got a few browser tabs open. And so if you're maybe a smaller shop, you might have maybe 5 security vendors. You got your AV and your firewall. And they're already actually kind of that's actually just at a small shop, and that's already kind of a lot of overlapping data, which is a little interesting. Now, if you go to a bigger shop, they might have 100 security vendors all feeding different types of data around that incident, and you're the poor IT person trying to figure out what's going on, and you have this 100 things. And that was kind of true 10 years ago. Now, it's the next level is like, oh, by the way, we just some of these aren't even logs, they're APIs. There's all these cloud, maybe reputation scores and things like that. And by the way, we're actually a bigger shop, so not only do you have one database collecting these logs, we actually have both Splunk and Elasticsearch, and we're actually spinning up maybe a Neptune server. And so you have all these tables and indices, and it's kind of a mess. And if you start adding it up, maybe at a smaller shop, maybe you have 10 million events, security relevant events a day. If you're a bigger shop, maybe a billion, something like that. And when you're looking at that IP address and trying to thread that needle, that's what we're looking at. And they might have individual vendor tools for looking at these things, but ultimately, once it starts escalating, you're going to go look at that central data store. You're going to do searches. You're going to get maybe some histograms and a bunch of next buttons on those search pages. And what will happen from there is probably you're going to open up Notepad, and it's like, oh, it's IP 10608. It's at this time, and you're just starting to record your paper trail. That's from the individual analyst perspective, and because we actually live in a team environment, unfortunately, just one person can't do all the things. If you take more of the manager perspective or anybody with a bit of responsibility on this, what you're also hoping is that it's not pool night. Your top analysts are not all drinking, and it's just the college new grad who's now all of a sudden handling this one, and this actually might be the Russians. So this is the reality of a lot of investigation teams. And so from the graphistry view, we're kind of trying to figure out how do we get this closer to this ideal of like we know things could be better. Computers are doing things. AI is doing things. There's this graph thing. Like, shouldn't things be better? I personally have a kind of a performance background, and so for me it's interesting to kind of break down what actually is happening there, and then if we're going to make this better, what are the things we need to chisel out? And so if I was kind of unwind a bit about what that flow I just described is, well, one is we need to pull out the right data, so we need to query across these data sources, our logs and our APIs. Once we get that data, we need to kind of figure out the correlations and the connections between them to figure out what's actually important. Maybe computers could help us there, but then there's also a bit of this analyst aspect where there's a lot of fuzziness here where we're going to have to reason about it, and we're actually probably going to have to go back and pull out more, right? There's this iterative searching. And then only at the end of it am I going to start taking action, or maybe I'm kind of looping between searching and taking action. And so as a performance person, I can't just say, hey, we're going to use AI and solve step number 2 and go home. We actually have to solve all of this. And so when I talk about investigation, I mean that full iterative end-to-end process, and that's really what this talk is about. So I'm going to do a little, our first demo here. So let's step back a second. Okay. And so as a kind of a quick introduction to the graphistry platform, we'll be doing a few more demos here, but I just want to give a high level of just how we can do that simple process quickly. In the graphistry world, we might, first of all, just connect to a bunch of data sources. I'll be doing a bunch of Splunk stuff today, and then later Neptune. You can actually want to really connect across all those different data silos. But in this case, the idea is that instead of starting by writing that initial, jumping into, let's say, your FireEye vendor product and doing a search there, or jumping into your Elasticsearch or Splunk console and doing searches there, the idea is in graphistry, you could just type in the alert ID. You pick out the type of investigation you're doing. So for that 10.16.08, maybe I'm running a botnet investigation, but maybe I'll do like a spear phishing investigation. And the idea is you want to have the multiple steps of an investigation of data gathering and data correlation actually already set up ahead of time. You want your top analyst setting that up. And so then as an analyst, all I do is I put that in, I hit run, it gathers the data, puts it on screen. And then when I say puts it on screen, we actually pull out all the logs, which I'm kind of showing here, and then you want the tool to kind of connect the dots for you. And so in this case, for example, we have one log line with, it looks like we pulled out a few different types of entities in here for you. So for example, maybe there's some file transfers, so we want a hash file. Maybe we're looking at accounts, and so we want IP addresses or usenames. Anything in the logs should be connected onto screen. And the cool thing about graphistry is that you can actually, or one of the cool things, and what this talk is about, is we can actually, instead of just doing one step of investigation, you can hit run all, where we actually iteratively query across your different data lakes, stitch that story together, and we actually have what we see now as 6 steps deep. We see a lot of the connections in the data. I'll be doing further examples where we actually dig into the meaning behind that, but I wanted to give a feel of how what today might take an hour, Graphistry is turning into literally minutes. Like this is a live query I just showed you. And you could think of the number of Splunk queries underneath at each level that we're unfolding. Let's jump back here. And so from our experience working with different sized enterprises and government agencies, we don't actually believe in a one-size-fits-all. So when we're talking about investigation platforms and graph platforms, I think it's useful to figure out if you're going to have a cross-cutting capability, what you're actually looking for. And so the example I was pointing to, I just did just now, the poor incident responder having to, getting that alert and having to get it done. That's more at the tier 1, tier 2 level where it's urgency and automation and you need to really zip through things. I'm guessing a lot of folks in the audience here, they might be more at the maybe tier 3 level, maybe a researcher or data scientist, or maybe doing some sort of SecOps or NetOps, that kind of stuff. You actually have a bit of time to code and you're dealing maybe more with volume and you're trying to find patterns and like you're trying to figure out how is today different from yesterday or why did the system go down, that kind of stuff. And so when we're talking about the investigation platforms and what we want to do with these systems, sometimes it's just about recording the workflows and just letting people zip through it, but other times we want to actually say, hey, how much data could we put in here? Could we dynamically pivot? Could we dynamically drill? That kind of stuff. And what's kind of cool about that, and I keep saying this, like I've been using that as the example of the security thing, of kind of the security team where an incident propagates across different classes of analysts. Fraud teams, for example, work the same way. You have like the tier 1 fraud where it's the simple thing. They might have 5 minutes to respond, but maybe you have it escalates to somebody who has an hour. Maybe you have a data scientist who could take a week. And if you go to, for example, I was just chatting with Brad about anti-human trafficking projects. That's the same exact thing. You have different tiers of that. Graphistry, we all even talk to, for example, pharmaceuticals. And so that same pattern we've been finding to be repeating. And so when we're building these systems, the way that we've kind of architected for it to work is basically we want to make it an extension of the current investigative flows because there's already these big entrenched workflows. And so our view of how this needs to work is basically there are already a bunch of data lakes out there. And so maybe you have Splunk, maybe you're starting to add Neptune, and you're working with those. And then what's more, once you start hitting this level of maturity, you probably already have, for example, alerting and rules. Maybe you're experimenting with AI systems. And now this starts actually getting into things like APIs. And so we're actually dynamically need to be hitting APIs. An architecturally difficult thing about building these systems is that, and what we'll see a lot of vendors will say, hey, we're going to do all of that, just buy our Hadoop cluster, install 1,000 nodes or whatever that is, and we'll suck in all of that, and then we're going to provide you this particular analytics solution. That was okay 5 or 10 years ago, but once you start hitting scale and enough diversity, you're now you're hitting scaling problems with the vendor, and you're also hitting lock-in problems with the vendor. So one of the things that we've been trying to figure out, and kind of an important thing as we've been working with others, is switching to more of a BI approach and kind of taking lessons from that world, where what we say is, as long as something has an API, the job of kind of your investigative tier is to just query across those. And so we could trust Neptune to do the scale out for graph queries. We could trust Splunk to do scale out for maybe log queries. And the job of the investigative tier is to kind of do the on-the-fly data fusion. And so instead, once you have that kind of composition, and so you have kind of more composition across the different tools, what we look for the investigative tiers now, basically 3 things, and this is where a lot of our time goes. First of all is, could we do the actual graph analytics? And so most of the rest of the talk on my side will be about that. Once we have brought in the kind of graph perspective to a lot of these investigation problems, then things get a little interesting in 2 ways. One is what I just showed you about that workflow automation, and so ways that we can kind of allow people to map out their incidents and zip through them. And the second thing is actually the GPU aspect, where individual steps of investigation maybe one of your queries returns a lot of data. Generally, the answer is a small one, but for that one step, your kind of your visual tooling and your investigative tooling shouldn't just fall over if one of your steps has a lot of data. They should help you print it back down. And so that's where the GPUs come in. And I actually want to make one note is it's actually been very cool for our team to have, we were actually one of the first users of GPUs on Amazon. And so it's been very cool to see, I think now it's I want to say the P3s just came out recently. And it's been fun to watch for every version jump to see our platform go a bit faster. So I want to talk a little bit, go a little more in detail on when I say graph, what I mean by graph, especially in the investigative context. And for contrast, I think it's useful to look at logs, which is basically what a lot of folks are dealing with. So as an example, let's say I was maybe doing more of a auditing perspective. Like I want to look at all of the day's alerts, and I want to understand, the entire day's alerts or the last month's alerts, and start to did I miss anything or their groups or whatever. So if I ran a normal kind of tabular query against that, I can get a table with a bunch of IPs or users or alerts or things like that. Or if I'm doing DNA analysis, I can get different markers, or if I'm doing machine learning, different features. The thing about that is, let's say I have a bucket of alerts. I'll say, oh, I have 10 priority 10 alerts and 3 priority 5 alerts. And I have if I have a nice just bar graph, I don't really understand the relationships between alerts and different buckets of it. If I have just a search result, it's very opaque. I don't know what's going on in that. I'm just scrolling through logs. While graphs lets us start seeing relationships and actually drawing out and reasoning about relationships between all the events and entities and those results. And one way to think about it, and I'm talking about, is it starts taking us away from these one-dimensional bar chart views into high-dimensional, if you have a lot of columns in your data. Graphs lets us start reasoning about that. And one way I kind of say that is I start describing graphs as sort of a map, like the equivalent of maps, but just now instead of for physical data, location data, now for any sort of data, as long as you have a lot of columns, graphs can let you reason about all of the values in them. So I want to give 2 examples of that. So the first one I think it's interesting to think about the types of questions graphs let us answer. Once we start modeling we still will work with our event and log data, but once we think about them as graphs, we can kind of naturally start answering questions that are today out of reach. So for example, if you look on the first row here, we have some type of nodes laid out. Let's say they're ordered by time. I can actually start reasoning about progression and behavior, which is often an important thing in an investigation. In this case, I see, oh, it's kind of this nice linear flow, but it branched. So that can be a really hard thing to describe if I'm just using bar charts, right? How do you show that? Another one is okay, well, I've got a bunch of events and entities on screen, and maybe I'm trying to reason about what's going on in the system. Well, that's patterns, and that's kind of patterns and correlations. Could I see kind of similar shapes going on anywhere? Conversely, maybe I'm doing more of a, I'm kind of doing an audit, and I want to see what are the outliers? What are the things that are not matching the main patterns, or is there a pattern to the things that are not matching the main patterns? And so graphs give us a natural way to do that, where if I just had a bunch of bar charts, I can't really talk about that. And then the final thing I think is interesting at a very low level of what graphs gives us is it just lets us reason about entities and scope. And so if I'm trying to do a 360 view on an IP or on a user or on an account, I can actually say, what are the things involved with that? And given any one thing, what's nearby? And again, if I'm just doing search, if I'm just doing bar charts, it's hard to see that stuff. Even if the source data is the same, without the graph perspective, it's just very hard to figure that out. A thing we end up doing a lot of, for example, if you're adopting Neptune or you're working with, basically if you want to introduce graph to your workflow, the question is, how do you bridge the event and log world to the graph world, right? That's kind of step 1 for a lot of this, and it ends up being just a recurring thing. And there's one thing that we do a lot that ends up being important here. It's got a complicated name, but it's a really simple concept. It's called a HyperGraph. It's entirely optional for how you work with these systems, but it ends up being really nice. And it's basically all it says is take each log line or each event, just make that a node. And as soon as you put that on screen, you can say, and our visualizations will do this, is we'll pull out any of the interesting entities mentioned in your log line, also put those out on screen. But now instead of just reasoning about your entities, at the same time we're reasoning about events at the same time. And so this ends up unlocking a bunch of stuff. And so I think one interesting trend we're seeing out in the field here, once you have that temporal modeling, gets unlocked. And so we've been seeing different names for this. The name that's been most interesting to me has been a correlation service. And so this ends up being one of the big use cases for different types of teams for graph. And so as some examples of where this fits in, and this is actually where Neptune really shines, is if we kind of treat this in maturity levels, the first one is basically prioritization. And so let's say we have teams responding to events or investigating events. The first step of prioritization is basically saying, instead of playing whack-a-mole with individual log lines or individual alerts, can you have all that kind of that type of transforms going on behind the scenes? Can you group those together? So when you're, instead of addressing one event, you're now addressing a cluster of them. And once you have these nice groups of alerts, can you then start prioritizing the groups? Like, is this this group involving important things or important assets or anything like that? And then next level of that is like, okay, well, great. So now we have a nice ranked list of things. So we've now just kind of cut down a lot of the effort that a lot of our teams are spending. Now when they do pick something up, can we increase the amount of visibility they get for any individual thing? So imagine we were looking at that original IP address, like 10.6 whatever. What groups is that involved in? If we have a correlation service, all of a sudden you have the thing and you just hit expand and bam, you have like the context around that thing. You hit expand again, you get a bit further context. And there's a really funny trick that I just played on that previous slide of the hypergraph. So and it's kind of the reason why this works. All the things I just described are the things you would expect some sort of magical machine learning or AI system to do. You know, grouping, prioritization, correlation, things like that, right? And in the scenarios I've been talking about, we've been talking about regular analysts. This is like the IT crowd, this is the anti-fraud crowd, just like normal people doing stuff. Yet behind the scenes, I was basically talking about core machine learning operations, right? And what's more, I've been providing a visual intuition for these things. So once we did that hypergraph modeling, and once we actually assumed like a system like Neptune is helping us answer these queries, what we basically just said is we basically turn regular analysts into folks who are actually driving AI-powered or machine learning-powered systems. And that's actually a really big thing. And so one thing I've been starting to talk about for Graph is it's actually starting to provide a user interface for dealing with high-dimensional data, dealing with AI systems, things like that. It's the first time we actually have an interface for analysts to drive this stuff. If you're on the math side of things, it's actually very simple intuition, which is basically an edge in a hypergraph is basically, if you have a correlation matrix, it's just one of those like weights. And so the weight of a hyperedge is the weight in your correlation system. And that's just and the hypergraph is a transform to go from your event logs to basically this type of modeling interaction model. That, the thing, again, if I'm just a security analyst or I'm trying to do anti-human trafficking, I really don't want to know about that. So in Graphistry, we just make that a button to run clustering. So that, I'm going to do one more demo. And this gets more to maybe the tier 2 or the researcher level. Let's grab this here. And so this is where things like, what I just described is basically doing, oh, we're still not quite here. I need to take it. Great. So this is a fun example. So let's say we have a system like Neptune behind the scenes where we can just pull out 100,000 of the most important alerts from the year and just try to reason about it. This is actually running on a real enterprise data set here. And once we have things like GPUs, what we can load in and render a lot of data and actually interact with it in ways that, especially in just a regular browser setting, was previously impossible. So in this case, what I want to provide an example of is where we just wanted to see for a Fortune 500, what does a day's activities look like? Like, what is the alerting activity? So each node here is an IP address, and each edge is an alert, and this is an internal device. And each edge means that there's some sort of network alert between two devices. And what we wanted to figure out here was once we were able to quickly get back all the devices kind of having alerting activity within our enterprise, what's going on? Could we provide a high-level view? So once we got that query back from the scale-out system, Graphistry just put it on screen, and now we can do a few fun things. The first thing that we're going to do is Actually, first fun thing is I just want to note, we have 64,000 devices on screen and about 106,000 alerts on screen. I'm just doing a very smooth user interface to that. And so that's just how one of the ways that Graphistry uses GPUs on the front end. The next thing is you actually see when I hit this play button, we're actually doing kind of clustering algorithms and things like that on the back end. Normally when you're dealing with graph systems, somebody runs clustering and it's interactive. We're normally dealing with maybe 1,000 or 10,000 nodes. Graphistry, we can do about 1 million and it's fine. And part of the reason that works is we're actually using Amazon's GPUs on the back end. And where this demo gets fun is what I'm going to do really briefly is I'm going to color each alert based off of the type of vendor that generated it. And so we're going to recolor the edges here. And I'm basically trying to answer what's going on. Whoops, actually. I want to know actually not the type of a vendor, but I want to know actually the device that did it. So on the fly, I'm just kind of using the data to control the graph. And what we see here is mostly we have red firewall activity. But what's interesting for my data center is that there's actually all these other things. So once I get rid of all that firewall stuff, which normally an investigation would have fallen over by this point because we didn't have the acceleration. But in this case, now we actually have, we were able to do that filter. I can now recluster. And now when I zoom back in, what's kind of interesting is for that day, for this Fortune 500, where we had, what was this, like 60,000 devices with actual alerts that somebody had to look at, we actually realized it's only a few clusters of actual alerting activity. And so now we can do normal type investigations like ask, what's going on over here versus what's going on over here. Let me jump back. And so hopefully as I'm going through this, you're getting a feel for, as I talk about doing an end-to-end investigation, how like the automation's letting us zip through and now the acceleration for if any point has a lot of data. So kind of briefly on this one, I actually showed several cool pieces of technology in play to let me just load basically all the computers in the system on screen. First one, what you saw on screen is I just rendered a lot. So this is kind of like a video game. It's kind of that same notion of a 3D engine for a video game, except for when we're working with data, we're not really interested in photorealism, but we're actually just interested in having a lot of stuff on screen. And so we had to basically write our own essentially SVG engine, but like kind of bulk optimized, and we had some interesting WebGL stuff there. The next thing that you saw going on behind the scenes was when I hit that clustering button, which was when we do want to see all this stuff on screen, even if the answer was ultimately those few clusters of stuff, I needed to get there. So I needed to run clustering, I needed to run filtering, all that stuff. And so we were using GPUs on the server, and we've been actually creating a lot of GPU frameworks for doing that stuff. And then, and so that's both kind of on the machine learning side, but also just interactive analytics, filtering, reductions, things like that. And there are kind of two interesting tricks to that, and this is stuff that I think other folks who are on the GPU side of the world may want to duplicate. The first thing is we've sort of pioneered this model of client cloud streaming, where the idea is we've rethought of how visual frameworks should work as basically GPUs on both ends. And so when I think of what my interaction section is, as long as somebody has just like Wi-Fi, is that we're going to connect those two together. And that's the compute platform. And the second thing we have here is we've been working with something called the arrow format, which is basically a columnar format for representing a lot of the data going back and forth. From the analyst view, this doesn't matter so much, but from the folks who are actually building these systems, if you're pioneering these things, what this is basically unlocked is the ability for different GPU tools to work together. And so while I've shown a couple of cool things in this talk, what's interesting is there are other AI vendors, there are other analytics vendors who are starting to pioneer other technologies, and we've been working with NVIDIA a little bit actually with Brad's team on this kind of initiative of having basically zero latency communication across GPU systems. And so if you're excited by systems like Spark, this is basically the next generation, in my opinion. Like this is how we get the next level scale and next level interactivity. Like how do we get 10x or 100x more? So if you're into that kind of things, actually our project was recently added to the Apache Foundation, and it's also called Go AI. So feel free to talk to me after. So stepping back, really, what I was trying to communicate here is investigation within an enterprise setting is this end-to-end thing, both in terms of the individual analyst, but also at the team level, and expands all the way from grabbing data to correlating data, connecting it together, making a decision, repeating that process, and then kind of passing on to the next team. And so we've been thinking about that as an optimization problem end-to-end. Sometimes we could do it with technology, so we'll be connecting back to the Neptune side in a second. I showed a few examples from GPUs, and sometimes we have to think about more broadly about the glue, like the workflow stuff I was showing you, and how do we actually compose it into the system. So there's kind of a lot of architecture and things that you want to do if you want your project to succeed, basically. With that, I actually want to bring it back to Brad and kind of the collaborations that's been kind of starting up.
Okay, great. So the visualization part is really cool, and the analytics are really cool. But you want to process a lot more data than you can even visualize with a tool like Graph History. And you need tools that allow you to do that. And so certainly in the cyber domain, in the network analytics domain, things like graph pattern matching, various different kinds of analytics, they're very important for helping you to find from a very large set of data to get something that's much smaller that you can actually manage in an individual investigation. And so there's a couple of different options for storing and managing this kind of data. One thing you could do is you could use a relational database to store this kind of information. The challenge is that this information is really very highly connected. It's fundamentally about how devices communicate and how they communicate with each other. And so using a relational database for this kind of highly connected data just isn't really a very good fit. If you use a SQL query to traverse the data, you end up writing a lot of complicated join operations. It's, as the joins expand, your query performance degrades. Graph processing has very different I/O workloads than relational database processing. And so relational databases just really aren't optimized to process graph queries very quickly. And to Leo's point about diversity of different data sources, you never really know when you're going to bring on a new sensor in your network and need to process that data. And so in general, the data is very dynamic. And so relational databases really aren't very strong at sort of handling schema evolution and changing. So there's definitely challenges there. This is sort of I won't dwell on this in this talk, but this is really kind of an example of the difference of the challenges. Here on your left-hand side, you see the relational model. And that's really sort of an HR system. And suppose that you had a question, you had an employee leave suddenly, and you wanted to answer the question, well, what skills do they have, or who do they work with? If your data is stored in this model that was intended to support a business process, it's really very difficult to ask that kind of question. Whereas if you look at the model on your right, and you have it in a graph model, it's much easier to answer that question. It's easier to frame it if you use a graph query language. And so a graph database is a database that's optimized to store this kind of highly connected information and supports query languages and APIs that are concise and efficient for being able to express traversals over the graph. And so this is really the motivation for why we developed Amazon Neptune, which we announced yesterday. Amazon Neptune is fast. It's designed to process interactive graph queries. So it's designed for graph applications that need to have very high throughput with low latency graph query answering. It's designed to be very highly reliable. We support multi-AZ high availability. We support up to 15 different read replicas. We support encryption at rest. And it's easy to operate, fully managed. We support backups, point-in-time recovery. And for the graph space, we give you the choice of different APIs and models that you can work with, so you can use the ones that work best with your application. So this is just a very quick snapshot of Neptune's overall architecture. So they're working down from the top. You can see the breadth of different use cases. Here we're focused on a cyber use case, but there's a lot of different use cases for graph. We support two sets of APIs. One's called Apache Tinkerpop, and it has a language called Gremlin for imperative graph traversals. And the second is a set of standards from the World Wide Web Consortium called the Resource Description Framework, RDF. and its query language, Sparkle. Neptune itself at its core is a purpose-built engine that's optimized for graph processing, and it's durable and fully ACID with immediate consistency. And then it sits on top of a cloud-native storage layer. And that's what allows us to give it the sort of the enterprise features. So that's cool. Neptune seems nice. I hope you think so. But how do we put it all together for this kind of use case? And so what we wanted to do was to sort of provide an end-to-end concept of how you would take some sort of data that you had, use Neptune and other AWS tools, and then perform an investigation using Graphistry. And so we started with a data set that's from a sort of research activity called VAST 2013. It has a set of net flows that were taken over 2 weeks. There's about 14 million net flows, as you can see, 1,400 devices. And what's going on here is there's a denial of service attack that's occurring. And so what we want to do is take these net flows, put them into some kind of graph representation, maybe do some processing over it, add some information, add some analytics to it, and then put it into the visual investigative tool and try and find out more about it. But there's a few important steps along the way. And so what we did here is we took the net flows that are available on VAST, and you can go to their website and download them yourself if you're interested. And we put them in S3, which is a natural place to start. And then we used AWS Glue to take a look. We created crawlers over these net flows. They're CSV files is what you can download. Created tables in Glue to represent all of the different attributes of the net flows. But then we also wanted to do some summarization. And so we wanted to look in aggregate. Each net flow represents a connection over time between one host and another with some attributes about the number of bytes, the IP addresses, et cetera. And we wanted to do some roll-up and aggregation. So we wanted to look over this period of time, how many net flows between two hosts occurred, over what different ports did they occur. And so we used Amazon Athena to be able to run sort of serverless queries over the data that we had in S3 to be able to aggregate it, put it together into a form that we could run a GPU-accelerated correlation algorithm over it on the P3 instances, and then have a graph representation that can add those correlation attributes into Neptune, and then ultimately show them in query in Graphistry. But before we get to that, just quickly, I wanted to show the concept of a net flow as a graph. This is looking at net flow as an RDF graph. And so you can see, as Leo was saying, you're modeling the event as the edge and some of the attributes. This is a similar kind of way. So the net flow itself is a node in this model, and there's edges relating to the IP addresses, ports, packet size. And so this is just an example of looking at net flow in a graph form. And then we also wanted to look at doing a community detection concept over this data to provide some labels about what communities these nodes and IP addresses in particular belong to. And we chose the Newman spectral modularity algorithm to do this. It's a fairly well-known group detection algorithm. But in particular, we chose it because it can be solved iteratively with a power method. And so we can use some of the features that became available with NVIDIA's release of CUDA 8 and CUDA 9 with their support for the NVGraph capabilities, in particular the SPMV operations. And so to kind of put it all together, this is an example of sort of showing what we did in Athena. This is our query in Athena to aggregate that data. We then took that information and developed into the sparse matrix representation that we did to include the community detection, and then added those labels into the graph, which we stored into a Neptune graph database. And then I'm going to bring Leo back up, and he'll let you see the result of all of this. So,
thanks, Brett. Yeah, so I'll give this a second to turn on here. So I want to actually do a pretty fun demo of putting this together, where I'm actually going to teach you a little bit about hunting, and so which is kind of not something Some people here might do it every day, but I'm guessing most do not get to. And so what we did with this is, for this demo is we kind of like as a standard, any sort of data system, you make your connector, you teach it about the tables and things like that. So we just taught Graphistry about the kind of the algorithms that Brad's team had set up. And so those are just could be, instead of having to, once somebody writes some of that SQL the first time, from then on, the rest of the team doesn't have to deal with it. And so we kind of just set that up, and that, again, that kind of visual analytics playbook, so that's now just ready accessible. I don't want to attempt to demo gods too much on this, so what I want to do is just jump directly to the visualization we generated based off of that denial of service. And so I kind of had set that up ahead of time here. Let's go full screen. So this is kind of fun. So also with maybe a little bit more background here was an interesting thing is the first time we took a look at this data set, and sometimes when we actually ran some trainings, we actually did it with Spark. And with Spark, it took us about 30 seconds to a minute on kind of a small cluster to do those steps that Brad was describing before, while Neptune is kind of more purpose-built for this kind of computation. Or it's more focused on, instead of batch, on interactivity. And as we're doing interactive investigation, that's actually very exciting to our team. So where I wanted to go with this is once we kind of did the Neptune step, now we get some pretty fun views. So what we're looking at here is like each device is a node, and then each edge, let's pick one that makes a little more accessible here. Each edge represents a net flow, so kind of that roll-up that Neptune could have computed of like, how many bytes passed through, how many ports were accessed, things like that. So if I was just gonna, first of all, this is cool because kind of like that our earlier demo I showed, basically no matter the size of your system, like even if you're actually Netflix or Google scale, we can actually show it. So that's cool. Like that's a cool thing. And what's more, now we can actually work with it. And so when I'm doing, we knew for the context for this data set is that there's a denial of service attack going on. So the first thing we might want to say is, let's see the denial of service attack. And what a denial of service attack means is basically some devices are just trying to overload some kind of core servers, and so they're just kind of hitting them a lot. And instead of having to write a lot of SQL or anything, we just want to just make it all sliders. So one of the data attribute columns coming out of systems like Neptune is like the rollups. One of those we pulled out already is attempt count. So I just dragged along here. That auto-generated that filter for me. We also have a mode where if you only want to show the devices that actually have stuff, kind of events and edges on them. And then I'm just going to recluster what's left. And then we'll see what kind of the clustering algorithm tells us is left. And this is kind of cool. So what's going on here is in purple, it looks like we have web servers. And then in green, we just have little, looks like in green, we just have little devices, just like endpoint users. And so what's kind of interesting is for this denial of service attack, what's actually not super surprising is somebody who's attacking the public web servers. So if I was going to try to take down a company, that's not a crazy thing to do. And to just validate that, we can say, for example, on this edge, it looks like in that 2-week period, we had about 1 million, that one computer hit the server about 1 million times. So that's probably not just somebody refreshing their email, so something's going on. Now, you don't really need Graph or Graphistry or Neptune to do that. What you need an investigation tool to figure out was that it? And so and as a hunter, I'm trying to figure out, are there other indicators of compromise? Was there other escalated activity? Was the scope, progression, all that stuff I was talking about before. And so as one very kind of simple example, actually the reality is as a hunter, I normally would be working with much richer data sets than just the net flow, but for this demo, this is kind of a nice example. And so one common thing I might want to use to pull out signal here is, if you have a bot doing the denial of service, it's probably all on port 80, but what else is going on? And so I might want to look at the ports being active between the computer communications to see if there's anything else. And that's kind of a nice hunting signal. And so as a simple thing I'm just going to ask is, let's just color based on the number of ports, because maybe I can start seeing distributions on that. And so I just recolored the edges. White means only a few ports were active in 2 weeks. So for example, just one port here. While strong red, when I recolored it, means a lot of ports. And so it's maybe easier for me to see on my laptop. But I see, for example, for this web server getting hit by this device, I actually see there are about, 63,000 ports were accessed over that 2-week period. And again, this is not somebody refreshing their email. This is probably just this is probably a port scan. And so now, as a hunter, I'm kind of like, okay, that's already interesting. I've all of a sudden, instead of checking, looks like we've got 43 devices on screen, I've already honed in as one of the devices as interesting, and I might want to figure out, okay, on this web server, were there any CVEs, or like I know that there's a port scan looking for certain type of vulnerabilities and things like that. And so for me, this is kind of a very nice example where we were able to start in the beginning. We used clustering and community detection from Neptune to kind of get a feel for the data, and then by using the interactivity, we could dig in more. Kind of as another example where actually Neptune is useful, instead of me coloring based off of the type of the asset, I might want to actually color based off of the device categories that Neptune kind of communities figured out. What's interesting when I'm looking at this is for this web server, there's like blue and purple devices associated with it. And so I might need to be able to explain why are there 2 categories of bots basically hitting this, trying to hit this web server. So there might actually be more structure to what's going on. So anyway, this was actually a very exciting example for me because when the original data set was released, teams had about 2 weeks to kind of explain what was going on in this data set. But what I just showed you was basically a SQL query, or I think it was a Sparkle query in Neptune, and then just basically clicking around in Graphistry, and that was it. And we actually were able to flesh out a bunch of kind of not just the basic denial of service, but other incidents going on. Let me jump back. Actually, jumping ahead.
I think we have time for a couple of questions. If you're interested in the Neptune Preview, it is available. You can sign up for it. There's no cost for participating in the preview. There's some information there for documentation. And then additionally, if you're interested in learning more about Graphistry, a couple of pictures, I'll let people take some shots. If you're interested in Graphistry, happy to get in touch with them for a demo, or also for developers to talk to them about getting an API key.
Yeah, and we'll be hanging out after as well, so if you don't feel comfortable coming up to the stage.
Yeah. So, thank you very much.